Alright, let's see what happens when we do the experiment. Here I have a syringe filled with purple grape soda. I'm going to push the grape soda into the column and let the liquid go through into cup number 1. Now as I do that, the water is going to go through the column, but the dyes that are dissolved in the water are going to become trapped in the column. The column is designed to be sticky to the dyes, but not to be sticky to water. So water goes right through. And the liquid that's coming through is mostly clear because the dyes are getting stuck to the material inside the column. So then what I'll do is I'll try to rinse out the materials from the column using the two different mixtures of water and alcohol. First with the 5% alcohol and then with the 25% alcohol. Okay, so the water that went through, mostly clear, and now the dyes are trapped inside the column. Now I'll take the column off and fill the syringe with 10 milliliters of 5% isopropanol, so it's 95% water. And as I squeeze this through, it's going to wash out one part of the mixture, but not the other. The color that's coming out first, you can see there's a red color there. That is red dye number 40. If you look at the ingredient labels on foods that have food colorings in them, they tell you what the name is of the dye. Now there's another color that's in the soda. To give it the purple color, there's a mixture of red and blue. The blue dye is not going through the column right now. It's staying stuck because it's not attracted as much to the liquid that's going through the column. The liquid going through the column dissolves the red molecule, but not the blue molecule. So now I'm going to use the other mixture of water and alcohol. This one has more alcohol in it. It has 25% alcohol. So it's going to dissolve differently the materials that are inside the column, trapped in the column. So there's a little bit of red still left, but now it's coming out blue. This is blue dye number 1. Again, that's from the label for the soda. So the two different dyes are soluble in water, but they're also different in their solubility in the alcohol. The first dye is more soluble in water. The second dye is a little bit more soluble in alcohol. So when you increase the amount of alcohol in the mixture going through the column, it dissolves better and washes out. So the first cup, pretty clear. The second cup, red dye number 40. And the third cup, blue dye number 1. Okay, let's try that with the green Gatorade. So I'm going to push the green Gatorade into the column, and again the liquid will go through and the dye will be trapped inside the column. The liquid coming through is mostly clear. A little bit of one of the dyes might sneak through, but for the most part the dye is staying trapped inside the column. Yeah, I see a little bit of yellow is going through first. That's unexpected. I really thought that the yellow dye would stay trapped inside the column more. But now I'll add the 5% isopropanol. There are two dyes in this mixture. The yellow dye is more soluble in water, and the 5% solution has more water, 95% water, 5% alcohol. So the liquid that's coming through is mostly yellow. The liquid that went into the first cup, since the drink contains mostly water, it's not a surprise that the dye went right through along with the water because it's very soluble in water. But when you look at the column, you can see there's a blue color that remains. That blue color is not as soluble in water. It's the same blue dye that you find in the purple drink. This yellow is yellow dye number 5, if you look at the label on the ingredient list. If I add the 25% isopropanol now, just like with the purple drink, this time out comes the blue dye. They're the same blue dye number 1. This time it doesn't look quite as blue because there's not as much dye. But if you had more dye in there, it would look darker blue. But on the list of ingredients, they are the same dye. So the dyes differ in how soluble they are in water compared to how soluble they are in alcohol. The more soluble the dye is in water, the earlier it comes out. The first time the pink or the red dye didn't come out because the water went right through and the dye was trapped in the column. But it did get washed out when 5% isopropanol was used. Less alcohol, more water. In this experiment, the water dissolves the yellow dye a little bit better than it dissolves the red dye. So that one goes right through along with the water. 5% alcohol takes the yellow dye out of the column. It's more soluble in water than in alcohol. And then in both of these, the blue dye comes out when there's more alcohol, because that dye is less soluble in water and more soluble in the alcohol. Now what we can do is we can compare the polarities of these two molecules and use that to tell which is a more polar or nonpolar dye. The red dye number 40, the blue dye number 1, the yellow dye number 5. So here's an interesting follow-up question. I took some orange citrus drink and I put it into the column here, and I'm wondering, is this orange color from a single orange dye, or is it from two different color dyes, the red mixed with the yellow? And can I find out using the same solutions, 5 and 25% alcohol, to separate the different colors if they are in fact two and not one dye? So I'll take the column off and I'll load up with 5% isopropanol, and then I'll push that through the column and let's see what happens. Okay, so what I see happening here is that the orange color is coming right out. Now, does that mean that there's only one orange colored dye, or does that mean that there's two different dyes, the red and the yellow? And can I tell the difference using this technique? Well, the thing is, these two colored dyes are both soluble in the 5% isopropanol solution. So they would both come out at the same time, and if they came out at the same time, they would mix together and make orange. So if this is one orange molecule, or if it's really a mixture of these two, I can't tell the difference, because it could be one orange molecule that dissolves in the 5% solution. It could be the red and the yellow both dissolving in the 5% solution at the same time and mixing together and looking orange. So in order to find out if this is one molecule or two molecules, I need to try maybe some different percentages of isopropanol to see if there's some other way that I can get those to separate, if they really are two different molecules or just one. If it really is these two molecules, I need to find some difference between them then that I can use to separate them, because they're both soluble in the same 5% solution.